Howdy guys. So week 6, another week at home, looking like it could be another one or two. So I hope you all had a great midterm. And we're just going to keep going. You know, when it comes to maths, it's just sums anyway. So we're just going to keep going, motoring through the chapters. We're going to move on to something new today. Your tests are really good, very happy. And I'll show you where those are now. And if you have a look in the folder, the quizzes folder, you'll see that I've corrected them and put a comment down the bottom. And I'll show you where the marking scheme is. So if you want to check your answers and see where you went wrong, and what bits you can improve on. I put different comments on, like about functions you might need to look at something again, or try some of the revision exercise, try some of the exam questions. In order to improve in your functions and your arithmetic. So don't leave them there. Spend half an hour going through that exam, see where you went wrong, and correct those answers using the marking scheme. I'll show you what that is now in a second. And we're going to move on. Looking at shapes, things like words you heard before, perimeter, area, volume, looking at 2D shapes and 3D shapes even. And we'll motor on with that. So you shouldn't find today too taxing. It's only going to be 15-20 minutes, and then you'll have about a half an hour worth of questions to do, and we will go from there. But we're doing very well. We're level to where the other class are. The standard's very good. I'm happy. So we'll see where we get to over the next week or so. Okay, so back to the one now. Here first, I've put in new folders here. You'll see there, it's called measure. So it's measuring across the board. 3 chapters worth that we're going to do over the next couple of weeks. We're going to go through the first one really quickly because it's all stuff you know. But just before that, I want to go back into exam prep. See exam prep there and where the test was. So the test is here. And you'll see in your own quizzes folder that I've marked your exam. So I've given you a mark. And I've given you a percentage for that, and I've recorded that on VSware. And down the bottom here you have the marking scheme and how I gave out the marks and why I gave marks for certain things and so on and so forth. So it's all there for you to check. But have a look at your own exam first. It's there corrected for you. Okay, going on to today's stuff then. We're into this measure chapter. So we're in, I think it's book 1, chapter 20. Book 1, chapter 20, okay? Applied measure 1. Applied measure 1, applied measure 2, and then the higher level stuff based on both of those chapters. So I'm going to go through this really quickly because it's going to be stuff that you're not going to have a problem with. It's going to be nice and handy, stuff that you've done before, stuff you would have done in science as well. So quick recap, reminder, just in case. 10 millimeters. If I was to measure 10 millimeters, that's 1 centimeter. So 10 millimeters is 1 centimeter, or 1 centimeter has 10 millimeters. In a meter, in 1 meter, there's 100 centimeters. So I get a meter stick, there's 100 centimeters in the meter stick. And kilo means 1,000. So kilometer, 1 kilometer means 1,000 meters. 1 kilogram means 1,000 grams. We're dealing in measuring of 2D and 3D shapes. So we're dealing with size and length here. So it's all going to be meters, centimeters, millimeters, and so on. And then going into things like centimeters squared, millimeters squared, meters cubed, and things like that. Okay, nice handy conversion tool here. One that you'll need all through this is this one here. If I want to go from a millimeter to a centimeter, I divide by 10. If I want to know what I go from a centimeter to a millimeter, I multiply by 10. So if I say how many millimeters in 1.2 centimeters, when I multiply by 10, give me 120. Give me 12 millimeters. So there's in 1.2 centimeters, there's 12 millimeters. In 8.6 centimeters, there's 86 millimeters, and so on. And all the conversions are there for you to go between kilometers, meters, meters, kilometers, meters, centimeters, meters, and so on. That's a handy tool to have. If you're wondering how to go between these, but most of those you know already. You know there's 10 millimeters in a centimeter and 100 centimeters in a meter, and 1,000 meters in a kilometer, and so on. But just as a reminder, it's handy to have in the one spot. Okay, and here's I put this down as the homework. So most of this class will be you working by yourself, but this is going between 6 kilometers to meters, and centimeters to meters, and millimeters to centimeters, and centimeters to meters, and so on and so forth. But this exercise here, 20.1, is basically just using our important table here. So you'll use that to answer those 2 questions. But they're part of the homework, so you'll do them at the end. So I'm going to leave those to you, and I'll fly through the corrections the next day really quick. Okay, moving on then. Again, this is going to be stuff that you're going to be familiar with and you're probably going to know. Area, two definitions. Definition for area is the amount of flat space that a shape occupies. So not to be mixed up with the work on volume you would have done this year in science, is the amount of space something takes up. Area is the amount of flat space that a shape occupies. So, and perimeter is the sum of the length of all the sides of a shape. So if I was to say, to take something easy like this, and I was to say, right, here's your foot, oops, no, we don't want to use highlighter, I want to use pen. If I was to say, right, we have a football pitch like this, so a football pitch like that, and I was to say, right, the length here is, now I don't know the actual length of a pitch, but 100 meters, probably less. And over here, the width is going to be 60 meters. And I was worried about the area and the volume. If I want to find the area of a rectangle, I multiply. This is going to be your length, this is going to be your width. I multiply length by width, so it's going to be 100 by 60. Whatever that is. But if I wanted to find the perimeter of that, I add 100 plus 60 plus 100 plus 60. So it's going to be 100 plus 60 plus 100 plus 60. So you add up all around the outside. So that's going to be whatever that is. 320, something like that. Okay, so area, you multiply length by width if it's a rectangle or a square. And for perimeter, you're going to add up all the outside parts of it to work. And you've probably done that lots and lots and lots of times at this stage. So perimeter is the sum of all the lengths of the sides of a shape, all the way around the outside. So if you have something like this, both of these shapes here, you have a rectangle and a square. They're broken up into loads of little squares that are 1 centimeter squared each. So the way I could work that out, if I wanted to find the area of this of our one on the left here, I'd multiply our length, which is 5, by our width, which is 3, which would give us 15 centimeters squared. So remember, area is always squared. So I have that over here somewhere. Area is always squared. In this case, it's centimeters squared. If that was 5 meters by 3 meters, it could be 5 meters squared. But area is always squared. And to work out the perimeter then, so the second one, I add 5 and 3 and 5 and 3, which gives us 16 centimeters. And because that's perimeter and you're only adding up, it's not squared. You're only squared when you're working out area. And for those, remember, the science work from this year, if you're working out volume, it's cubed. For the square, squares are always the same. So if you have 3 on one side, you have 3 on the other side. So your area is going to be 3 by 3 is 9. And your perimeter is going to be 3 plus 3 plus 3 plus 3, which gives you 12. Okay, the way you can see this, L means length, L for length and W for width. So if you want to put this into a formula, it's L by W length by width, or you can do 2 lengths and 2 widths for a perimeter. So side plus side plus side plus side. Okay, same for a square. 4 times the length. So if up here it was 3, 3, 3, and 3, so 4 threes is going to be 12. And down here, it's L squared for the area. So it's just going to be length multiplied by length, which is going to give you your length squared. Okay, right. And all that stuff, I bet you know. If you don't, you can ask me on Wednesday or Friday, or email me if you want to, if you're not sure of any of this. But I'd imagine this is kind of stuff that you know already. Okay, bit of an example. If they give us a rectangular field, and the field is 100 meters long and 40 meters wide. So 100, and they have it in there, 100 meters by 40 meters. There's a square pond in the middle of the field. That's 30 by 30. So you can see there, they're 30 by 30 in the middle of the field. Calculate the perimeter of the field. So you can imagine there, you're just going to add up perimeter 100. This is 40. This is obviously going to be 100, and this is going to be 40. So you're going to add those up to get the perimeter. The area of the field, so part B, is just going to be length by width. It's the formula to calculate the area of a rectangle. The area of the pond, part C, is just going to be 30 by 30. And the area of the field, now this is where it kind of gets into a bit more difficult. The area of the field that is not covered by pond. So if we look at how they do that, well, they say, well, okay, well, the area of the field itself is going to be 100 by 40. Okay, which is going to be, so if you work out that, that's going to be 4,000 meters squared. Okay, 4,000 meters squared. That's going to be the area of the field. The area of the square, the pond, is going to be 30 by 30, which works out as 900 meters squared. So if this is the amount of area taken up by the pond, and this is the area of the whole field, the question was there, what is the area that's not covered by the pond? So you're going to take 900 away from 4,000, to do it here for you. 4,000 minus 900, which means 3,100 meters, is the area of the field that is not covered by pond. Basically, it's everything where there's no square all the way around here and so on. Okay, so you work out the area of one, of the big one, work out the area of the small one, take one away from the other to find the area of the field that's not covered by the pond. Other example, the perimeter of a rectangle, so all the way around the outside, remember that's perimeter, is 30 centimeters. The width is 5. Find the length of the rectangle. So I'm thinking, well, how does that look if I have to work that out? Well, so it's a rectangle, so a rectangle looks something like that. Shouldn't use highlighter. They're saying the width is 5. So obviously that's 5, this is 5. The total they told us is 30. So I'm thinking, well, I have 5 and 5, that gives me 10 in total. So the two widths are going to equal 10. That gives me 20 to use. And I know that this side is the same as this side. So I could work that out and say, okay, well, I have 20 to use up. That's going to be 10, and that's going to be 10. Or, have a look the way they do it there. They say, okay, well, 2 lengths and 2 widths is going to be equal to 30. So 2 lengths and 2 widths is going to be equal to 30 because perimeter is the whole way around the outside. Or they could say, well, 2 lengths plus 2 fives is going to be equal to 30. Get rid of the brackets. 2 lengths plus 10 is going to be equal to 30. So it depends on how good you are at seeing things. Like the way we did it out here, we worked it out. Nice and quick. So that means I'm going to bring the 10 over. 2 lengths is 20. Well, if 2 lengths is going to be equal to 20, L is going to be half of that, which is going to be equal to 10. So we worked that out, that here. Here's our 10, and here's our 10. So we worked that out. So there's 2 ways of doing that. You can do it using the LW, so work it out using algebra, or you can draw it. I'm a big fan of draw it, see what it actually looks like on the page and work it out that way. But we'll see that's not always possible as we go through this. Okay, going on then, you get these funny looking ones here. Find the area of this shape. You think, well, that's a funny shape. What formula am I going to use for that? Because it's not a square, it's not a rectangle, it's a couple of bits, isn't it? And usually before I even look and think about doing any maths here, I'll say, well, can I make it into a shape or shapes that are a bit more familiar? So there's a couple of ways that I could do this. I could draw a line up like that. That would give me shape 1 and shape 2. And I could find the area of this shape here, couldn't I? Because I know that if this is 6 here, and the total length is going to be 10, what's the area here going to be? What's that length going to be? Well, it's 10 in total. I've taken out 6, so this is going to be 4 centimeters. So I know that this side here is 4. So I could work out the area of shape 2 then. It's just going to be 4 by 4. And that would give me the area of that bit. Over here then, I know that this area here is 6, and this is 7, or this length is 6, and this is 7. So I could work out the area of this bit. So I could do 6 by 7. 7, 14, 21. This is going to be 42 centimeters squared. And this is going to be 16 centimeters squared. Add them together, and that would give me the area of the whole thing, wouldn't it? Get rid of all this for a second. What if I didn't do that? What if I said, actually, no, I'm going to draw the line this way. Like that. Then could I work it out? Would it be possible? Well, I know the total length here down here is 7, but down as far as here is 4. So this is obviously going to be 3 centimeters from here downwards. So this part here is 3 centimeters. So I could work out the area of this shape, 3 by 6, which would give me 18 centimeters squared. And then I could multiply 4 by 10 to give me the area of our big rectangle up there. So it's going to be 40 squared. Add the two of them together, and that would give me the area of the shape. And you do it a couple of ways, do they, down here? Oh, there's even another way of doing it. See this way here? I could increase that there. So I could make it into a big, massive rectangle. And I could work out, so the length of here is obviously 7 because it's 7 over here. This is 10. So what I could do is find the length of this square here, find the length of the whole thing, and take one away from the other. So they give you 2 methods, but I've just shown you 3 there. So there's a couple of ways of working these out. We'll do one more for you in a second, right? And I've marked a couple of those for you to try. Question 4, 5, 10, 4, 5, 8, 10, 11, 12. And I'll put all those together in a second. But if I take one more of these, one that I haven't given you, let me see. This one here. Question 7. The perimeter of a square is 36 centimeters. Find the length of each side and the area of the square. So all we know is that the perimeter is 36. So we have a square. The perimeter is 36 centimeters. You know, as in a square, that side is the same as that side, is the same as that side, is the same as that side. So I say, okay, I'll have 36 in total all the way around. So 36 divided by 4 is going to be 9. So each side is going to be 9 centimeters, 9 centimeters, 9 centimeters, and 9 centimeters. Okay, what question did they ask us about this? The length of each side is going to be 9. And the area of the square, so area is length by width, so area is equal to 9 by 9, which is equal to 81 centimeters squared. If I was to take any of these here, so for example, one of the ones I gave you, I obviously gave you the most difficult ones because I reckon you're well able for these. So here's one of the ones I gave you there. So here's a plan in meters. So they want the area of one tile, the number of tiles needed to cover the floor, and the cost of tiling the floor if each tile costs $3.50. So each tile is 25 centimeters for each side of each tile. So find the area of the floor. So to find the area of that floor, I would say now, and there's loads of ways you could do it. I could make it into one big square. I could, personally, I don't like adding to a sum. I would do this. I'd find the area of that side and the area of this one here. So find the area of both of those squares there, add them together to give me the answer to part A. For part B, the area of one tile. Well, they say, well, the side of one tile is 25. So you're just going to multiply 25 by 25 to find the area of one tile. The number of tiles needed, well, when you find your answer to this part here, you're going to divide that into your answer for part A to find out how many of those tiles it's going to take to cover the floor. And then your answer then, well, you know how many tiles, multiply that by 350, 3.5 to get your final answer. And most of these sums are pretty much the same. There's one there about another field, a garden and so on. The last thing I want to show you today, so I'm flying through this because I think you'll be well able for it. You might remember these from the entrance exam. This is, so if you have something that looks like this, so they call them a net. So it's basically a flat pack version of a cube or a cuboid. They give you something like that and it forms something like this. Okay, so a net then, for definition, is a 2D flat shape that folds to make a 3D solid. So basically this thing here, this one here, turns into that. Or if you have a cube, it can come from something that looks like that. So you could fold number 1 into a cube, or you could fold number 2 into a cube, basically folding it along. And they sell kids' toys for this kind of thing, to make various shapes. If we were in the classroom, I'd be giving you out various dimensions, getting you to make your own cubes and cuboids, but I obviously can't do that at the moment. And you'd be measuring and swapping them and taking areas and volumes and perimeters and stuff off them, but we can't do that. So we'll have to just do it from examples. So if you have something like this, then draw a net of a given rectangular solid as accurately as you can. Label the 3 different sides with the correct dimensions. Okay, so if you have something like, if you have a cube or a cuboid like this one here, and the side is going to be 8 centimeters, your depth is 4 centimeters and your height is 2 centimeters. So what they're looking for you to do then is to produce something like this. So what they're really looking for is for you know that if this here is 4 centimeters, this is also 4, this is also 4 here. If this one is 8, this is going to be 8, that's going to be 8. If there's 2 centimeters height there, that's going to be 2, that's going to be 2. So when you draw it, you should be able to show what does this one look like when it's unfolded. What would it look like if I broke all the edges, and it would look something like that. So you fold the sides out, you fold the front down. So you're just unpacking a box like you were pulling it asunder to put in your recycling bin, and so on and so forth. And I've given you a few of those to mess around. These might cost slightly more bother because it's a particular type of intelligence to get these done, as spatial awareness, and to kind of understand these. But we'll have a look at them the next day, and see how you get on. Okay, so I've just given you, I think, 2 or 3 of those to do. So like this one here, on question number 7, identify the vertex which meets the given lettered vertex when it's folded back into a rectangular solid. So what they've done is here, they've given you an unpacked box, and they want to say, right, when you fold that over, what comes into contact with what? So where does G end up? What is it connected to? Where does N end up? Where does A end up? L, K. Where do they end up? As you can imagine, this side here folds up, this side here folds up, and all of this goes up and around that way. So you can imagine what this cube would look like when it's coming, and what letter goes to what letter, and so on. So it's all about imagining what it would look like. So I've given you a couple of those, but I imagine you'll be well able. But if not, we'll correct them all in full, obviously, on Wednesday. Here's the homework all in a nutshell. The first one here is your conversions, is going from meters to centimeters, centimeters to meters, using that conversion tool I gave you at the very start. This one here is all working out your areas and your perimeters of various different things. So you've a couple of questions in there. And the last one then is those ones here, unpacking the nets, question 4, 6 and 7. So 11 questions in total, but I imagine well doable within the rest of this class time, but due to be uploaded to your homework section of your OneNote before class on Wednesday. Don't forget to have a look at your test, try and correct your test using the marking scheme, and get these homework questions done and uploaded. It's important I can see that you're doing them, and 2, you're kind of understanding them as well, so I can spot any mistakes and plan the next lesson if we need to go back over anything that people are having problems with. Okay, you have my email address. I hope you're all right and you had a great break. You had a nice break, and I will chat to you during the week. Mind yourselves. Bye bye.